Hi student, today I will teach you the laws of motion. In this chapter we will cover the contact and non-contact force. Then we will see the Newton's first law of motion, Newton's second law of motion, and we will see the Newton's third law of motion. Then finally we see gravitation. So the first topic for you is contact and non-contact force. What is force? You will know in class 6 and 7 and also in class 8. Force is a push or pull. Something, suppose this is a duster. If I am pushing it or I am pulling the duster, so this is what we say as force. But what is the actual definition of force? You know what happens when the force is applied on the body. Whenever you are pushing or pulling, what happens? What happens on the body? What the effects is produced on the body due to the application of force? Suppose this duster is lying on my hand and I am pushing the duster. What happened? The duster was in the state of rest. So while I am pushing the duster, it is coming in the state of motion. Say for example, while you are playing the cricket in the field, suppose somebody is hitting the ball and you are going and catching that one. So what you are doing over there? You are applying the force onto the ball to stop the motion of the ball. So here what the force can do? The force can start the motion of the body and the force can also stop the motion of the body. And along with this, the force can also change the direction of the motion of the body, and force can increase or decrease the speed or the velocity of the body. Or when the body is moving with certain velocity, you apply a force onto the body in the direction of the motion of the body. What happens to the body? The velocity of the body increases. And along with that, if you apply the force on the non-rigid body, these all are, I was giving you the example of the rigid body. When you apply a force on the non-rigid body, say for example, squeezing a gum tube, what happens? If you are squeezing a gum tube, you are applying the force and the gums are coming out. In the same time, what happens to the shape and size of that tube? The shape and the size of the tube is changed. If you stretch a rubber band, what happens? The size of the rubber band increased. It become elongated. So what a force can do? A force can change the state of rest or the state of motion, and also it can change the dimension of the body, that is the shape and size. So therefore we may define force in this manner. Force is that physical cause which when acts on a body, it changes the state of rest or the state of motion or the dimensions of the body, that is the shape or size. So we may note it down, the definition of force. Force is that physical cause which changes the state of rest or the state of motion or shape and size. So now what is the force? Force is that physical cause which changes the state of rest or the state of motion or the shape and size of the body. So this is what we say force. Once again I am saying you, force is that physical cause which changes the state of rest, the state of motion or the shape and size of the body. I have given you the different examples how the force is changing the state of rest, the state of motion, the shape or the size of the body. Now another thing is coming. What are the effects of the force when it's applied on a body? When the force is applied on the body, what are the effects is produced on the body? If suppose the force is applied on a rigid body means like hard surface, like a duster, a table. When you apply the force onto the table or onto the duster or onto the board, what happens? It changes the state of rest or the state of motion of the body. And if you apply the force on a non-rigid body, like gum tube or a hollow ball or a football, if you apply a force onto the football, what happens? At that moment, the shape and the size of the body changes. So these are the effects of the body when the force is applied on the body. So what are these? Number one, what is the effects? Number one, it changes the state of rest or the state of motion. So it changes the state of rest or state of motion it changes the state of rest or the state of motion. For example, you are kicking a ball, then the state of the ball is changed. If it was there in the rest, then it will be coming into the motion. Or if you are stopping a moving body, then the body will come into the rest. It was there in motion, so by the application of force it is coming into rest. So number two effect, what is that? It can change the shape or size of the body. It can change the shape or size of the body. Say for example, pulling a spring, a helical spring, if you pull a helical spring, what happens? It stretched, the size of the spring is changed. If you pull a rubber band, then what happens? It is pulled and the length of the rubber band increase. So if you squeeze a balloon, then what happens? The shape of the balloon is changed. So these are the effects of the force when it acts on the bodies. So now we see the kinds of force. Now see, on the point of view of application, the force can be classified into two categories. Now which are these? Number one is contact force and number two is non-contact force. So how many types of force we are getting? Number one is contact force and number two is non-contact force. Now we discuss what is contact force, then we see what is non-contact force. So at first we will see what is contact force. What is contact force? What do you mean by contact force? When the force acts on bodies due to making a physical contact on the bodies is known as contact force. Or the force acts on bodies due to a physical touch on the bodies is known as the contact force. That means whenever we are physically touching our body and making to move, suppose this duster is lying over there and I am pushing the duster, see, physically I am touching the body, or I am pulling the duster, physically I am touching this duster. So at that moment this force is known as the contact force. Now what is non-contact force? When the force acts on body even without being touched the body physically, then the force is known as non-contact force. So first you note down the definition of the contact force. When the force acts on the body by making it physically contact is known as contact force. Now there are different examples of the contact force. What are these? What are these contact force? Number one, force of friction is a contact force or frictional force. And number 2, tensional force or force of tension. This is another contact force. Then number 3, another force is there, normal reaction force. Normal reaction. Number 4, force exerted by a spring. Force exerted by springs. And number 5, that is your force of collision. So these are the examples of the contact force. What are these? Number 1, force of friction. Now, what is force of friction? When a body moves on a surface, either the body is sliding or the body is rolling, then the force acts in the opposite direction is known as the force of friction. Any body, when the body is moving on a surface, suppose this is the table, this duster is moving now, see over there. Now one force acts onto the duster, that is known as your force of friction in the opposite direction of the motion of the body. So always remember that the force of friction acts in the opposite direction of the motion of the body. Suppose, see over there, this is a table. So this is a table, and on this one body is lying. Suppose this is a wooden block, and the block is being pulled along this direction. We are pulling the block. That means we are applying the force along this direction. So force is applied along this direction while we are pulling the block, and during that moment this block will exert a force of friction in the opposite direction. Therefore the force of friction will come along this direction. Force of friction. See, this is the motion of the body. The body is moving along this direction because we are pulling. This is the motion of the body, but a force of friction always opposes the motion of the body, and therefore along this side the force of friction will be exerted. So this is all about your force of friction. So next we will discuss the force of tension. Now what is force of tension? When an object is suspended, a body is suspended by the means of a thread, then the weight of the object is being balanced by a force, another force on the string, which is known as the force of tension. Suppose, see the diagram, you will understand. Suppose this is a rigid support, and say this is a body, and this is the thread string. Okay, and this is your rigid support, and this is the body only. There is a body. Now this body is suspended with the help of the string. The weight of the body, in which direction the weight of the body acts? The weight of the body acts along this direction, vertically downward direction. That is, weight of the body is here along this side. Weight of the body, W is equals to M into G. Now, is it going down? No, it is not moving down. Why? Because the weight of the body is balanced by another force which is acting in the upward direction on the string, which is known as the force of tension. So this is known as your force of tension. This is force of tension. So when any body is suspended by a thread or by a string, then the force exerted on the string in the upward direction, which will be same as that of the weight of the body, the magnitude of that force of tension will be equal to that of the weight of the body, and this force is known as the force of tension. So I hope you understood about the force of tension. Force of friction and force of tension is over. Now we'll see normal reaction force. Now what is normal reaction force? When a body is kept on a surface, suppose a body is kept on a table. So you see this one. Suppose this duster is lying on my hand. Now is it falling? It is not falling down. Why? Because the weight of the duster. What is the weight of the body? W is equals to m into g. The weight of the duster is being balanced by another force which will be acting onto the duster, and it is acting in vertically upward direction, which is known as here the normal reaction. Are you understanding what is normal reaction? So I am showing you the diagram of this normal reaction force. See over there. Suppose this is a table. On this table the body is lying over here. Suppose this is a body lying on the table. The weight of the body is acting along this direction. W is equals to m into g, vertically downward direction. A force exert in the upward direction and which will be perpendicular to the surface. A force exert in upward direction which will be perpendicular to the surface. This will be normal, perpendicular to the surface, means 90 degree, and this force is known as your normal reaction. Remember this. So this force is known as normal reaction. Now understood what is normal reaction? Next we see force exerted by spring. You know that when the spring is compressed or the spring is stretched, then the force exerted, which is known as force due to or force exerted due to the spring. Suppose I am giving one example for you. Suppose this is the wall, and against this wall one spring is being placed over here. Suppose this is a spring. Now what I will do, I will compress or I will stretch, I will pull this spring. This is the wall now. I am pulling the spring along this direction. So when I am pulling the spring along this direction, another force exerted by on the spring only in the opposite direction of its displacement. Displacement is happening along this direction. Since I am pulling the spring, the force is acting along this direction. This is the force which is acting onto the spring. Now another force acts on the spring in the opposite direction of the displacement. That is known as your restoring force or force due to the spring. So therefore the direction of the restoring force, this is the direction of the restoring force. Restoring force will act along this direction. It will be always in the opposite direction to that of the displacement. Suppose now I will compress the spring. So this is the rigid support, same. I am compressing the spring along this direction. Whenever I will compress, the force has to be acting along this direction. This is the direction towards the wall. I am pushing towards the wall, compressing this towards the wall. So in this time, a force exert in this direction. This is your push or force. This is force is acting along this direction. Now during this moment, a force acts along this direction. That is known as your restoring force. So this all about the force exerted by the spring. So next example, that is force of collision. Now when two bodies are moving towards each other, then if they collide with each other, then they will exert a force on each body. One body will exerting on another body, and this force is known as force of collision. Just see this with the help of the diagram, you will understand this. So now say this is one body, this is your body A, this is your body B. So I will make, this is your body A, this is your body B. Both are, suppose body A is moving along this direction, this is the motion of the body A, and body B is also moving along this direction. This is the motion of the body B. Now, when they are moving each other and if they collide, suppose this is body A and this is your body B. This is your what? During collision. So when they collide each other, then both of them exerted some force. Now what force? This A is getting force due to B. B is exerting a force on A. That is known as your FAB. And on the other hand, the force of reaction due to this action, this becomes your force of action. The force on A due to B, that is your force of action. And due to this, same force is exerted on the body A. That means body A also acts the same amount of force on body B. That is known as your FBA. That means force on B due to A. This is force on A due to B, that is your action. Then this will become your reaction. Force on B due to A. And due to this reason, what happened? Both the body will move in the opposite direction. Therefore, after the collision, this is the during the collision. Now after collision, what happened? Body A will move along this direction. This is the motion of the body A, and body B will move along this direction. This is your after collision. So this is the force of collision between the bodies. So this all about your contact force. In all these forces, you must have noticed that the body is being physically contact. The body is being physically tossed. Therefore, such type of force is known as the contact force. Now next, I will teach you about the non-contact force. Next, non-contact force. The force which acts on bodies even without being physically touched, the force is said to be non-contact force. Means without touching the body, without contacting the body physically, the force which acts on the body is known as non-contact force. So can you say me, which are the non-contact force? Which force when acts on the body without touching, we are not touching, physically the body is being not touched, that is known as the non-contact force. Which are these? Can you say me? The see over here. See this duster. Now duster is falling down. Why the duster is falling down? What is the reason behind that? Again see. Why the duster is falling down? Here, who is pulling the duster? The earth is pulling the duster. You might be thinking, yes, that's right. The earth is pulling the duster. Why? Because one force exerted onto the duster, due to that the duster is moving towards the ground or moving towards down. Now why? What is the reason? Here the force of gravity is acting onto the duster. Due to that the duster is moving towards the earth surface. So the gravitational force is the example of one non-contact force. Here the gravity is not coming, or the earth is not coming to catch the duster and take it towards it. Is it coming? Earth is not coming. Rather, when I am leaving this duster, the duster is moving. Why? Because of the force of gravity. And this force of gravity is one of the non-contact force. So this is one example I have given. There are three examples of the non-contact force. Which are these? Number one, gravitational force. Number two, electrostatic force. And number three, magnetic force. So these three forces are the non-contact force. Which are these? Gravitational force, electrostatic force and magnetic force. These are the non-contact force. Now, what is gravitational force? I'll discuss now all these one by one. What is gravitational force? In the universe, you know that each particles are attracted by each other due to their mass, and this force of attraction acting between particles are known as the gravitational force. You know that when a body is freely left from a height, the body is moving in the towards the surface of the earth, and the force of gravity acting on the body to pull it towards itself. This is known as the weight of the body or force of gravity. This is also known as the gravitational force. Next, number 2 is here electrostatic force. The force between two charged particles, the force of attraction or the force of repulsion between two charged particles is known as the electrostatic force. Now you know, when two like charges are kept together, what will happen? Suppose this is one plus charge, this is another plus charge. If they are kept together, then what happen? They will repel each other. They will be not attracting. Here, repulsion. If I will keep a positive charge near a negative charge, then what happen? Here, the attraction. They attract each other. So, such type of force is known as your electrostatic force. The force exerted between two charged particles, either the force of attraction or the force of repulsion, is known as your electrostatic force. If two like charges are approaching towards each other, then they will repel each other, and this is known as the repulsive force. And when two unlike charges are approaching towards each other, they attract, and this is known as the force of attraction or attractive force. Next, number 3 point is here. Number 2 is over. Number 3 is magnetic force. You know that if a magnet is kept near an iron rod, what happens? The magnet will be attracted towards the iron, or the iron is attracted towards the magnet. Why? Why is happening like that? So that is due to the magnetic induction. Now, what is that magnetic induction? That we will be coming to know in the other chapters. So first you understand here in this, what is the magnetic force? The force of attraction or repulsion of the magnetic poles is known as the magnetic force. Now, in the same way, if the north pole is approaching towards the north pole of another magnet, one north pole of one magnet is approaching towards the north pole of another magnet, then what will happen? They will repel each other. If the north pole of a magnet is going towards the south pole of another magnet, what happens? They will attract. So the two like poles, they repel each other, whereas two unlike poles, they attract each other. So all these are the your non-contact force. So now we'll see what are the general character of the non-contact force. Are you getting any characteristics of the non-contact force? Can you say me? Think that if you have, or else I am giving you the general character of non-contact force. Now think, what are the general characteristics of the non-contact force? What are the nature of the non-contact force? Can you say me? Okay, I am discussing with you the general character of the non-contact force. Number 1, you know, between the three forces, how many non-contact forces I have discussed with you? There are three forces. One is your gravitational force, another is the electrostatic force, another is the magnetic force. Out of these three forces, all are attractive or all are repulsive, or all are both the attractive and the repulsive. Out of this, you will find that the gravitational force is always attractive in nature, and the other two forces, that is magnetic force and the electrostatic force, is attractive and also repulsive. So this is one characteristics of the non-contact force. What is that? The gravitational force is always attractive in the nature. Gravitational force is always attractive. Whereas the other two forces, that is your magnetic and electrostatic, they are both attractive and also repulsive. Number 2, the magnitude of the non-contact force is inversely proportional to the square of the distance of separation between the two bodies. Say for example, say one body is placed over here, another body is placed over there, and the distance of separation between these two bodies is d. Now, how the magnitude of the non-contact force is depends on d. If the distance between the two bodies is increasing, then the magnitude of the non-contact force decreasing. If the distance between two bodies decreases, then the magnitude of the non-contact force increases. So that is what another point of the characteristics of the non-contact force, that is the force is, or the magnitude of the force is inversely proportional to the square of the distance between two bodies. And how it is decreased? If suppose the distance between two bodies increase, how it is decreasing? It is not decreasing directly. It is not decreasing inversely even. It is decreasing 1 by d square. That means if the distance between two bodies is becoming double, then the force of attraction between the two bodies becomes 1/4. So in this way the force is decreasing. So these are the two general characteristics that you have to learn. So this all about the contact and the non-contact force. Thank you.